In spherical coordinate system, any point is represented using three coordinates: r, phi and theta. R is the distance of the point from the origin. Phi, it is exactly the same as we have seen in the cylindrical coordinate system, angle made by vertical half plane with positive x-axis. And theta is the co-latitude. It is the angle between r of the point and positive z-axis. Now let us dive into the details. Let us talk about the r coordinate first. R coordinate of the given point is the distance of that point from the origin. A point is like this, then r coordinate, r can be shown like this. A point is like this, then r will be like this, distance from the origin. Actually, for defining the r coordinate of the point, we assume a hypothetical sphere centered at the origin is passing through the given point. And r coordinate of that point is nothing but the radius of that sphere. For example, consider the same point again. So for defining r coordinate of this point, we assume a hypothetical sphere like this, which is centered at the origin and passing through the given point. And r coordinate of this point is nothing but the radius of this sphere. A point is like this, then hypothetical sphere passing through that point centered at the origin will be like this, and r will be the radius of that sphere. So r coordinate of any point is the radius of the hypothetical sphere centered at the origin passing through that given point, or it is also the distance from the origin. Any way you can remember. Phi coordinate is exactly the same as we have seen in the cylindrical coordinate system. It is the angle made by the vertical half plane with positive x-axis. Am I right? Everything we have seen over there, what is vertical half plane, how it is measured, when it is positive, when it is negative, everything we have discussed there. So phi is exactly the same as we have seen in the cylindrical coordinates. Now let us discuss about the last coordinate, that is theta. It is also an angle. It is the angle between the r of the given point and the positive z-axis. Or more specifically, theta is defined as the minimum angle between the position vector of the given point and plus z-axis. Again I am repeating, it is defined as the minimum angle between the position vector of the given point and the plus z-axis. Let us understand this pictorially. Let us say point P is given like this. So its position vector, OP vector, will be like this. It is the vector pointing from the origin to the given point. Am I right? So this is the given point and this is its position vector. So the minimum angle between this position vector and plus z-axis is nothing but the theta coordinate of this point, as you can see from the figure. A point is like this, then its position vector will be like this, and theta can be shown like this. Now my dear, you already know about the phi coordinate. It is also an angle. But if you remember carefully, in case of phi, we had two possibilities. You could write phi positive or negative, depending on the direction in which phi is traced. So similar to this, one might think that as theta is also an angle, it could also have two possibilities, positive and negative. But my dear, this is not correct. Unlike phi, theta can only be positive. Theta cannot be negative. Phi can be positive or negative, but theta cannot be negative. It is only positive. Because theta is the minimum angle between two vectors. It is the minimum angle between the position vector and the plus z-axis vector. As like this. Someone may perceive this angle as a theta, because this is also the angle between the position vector and plus z-axis. Am I right? But my dear, this is not our required theta. This cannot be our required theta, because remember, theta should be the minimum angle between these vectors. And out of these two possibilities, you can clearly see that which is minimum, which is our required theta. So what I'm trying to say you, there is no alternate way of tracing the theta. Theta can be traced only in one way, and it can be only positive. Theta cannot be negative. So in spherical coordinate system, we have three coordinates: r, phi and theta. R is the radius of the hypothetical sphere that is passing through the given point, or it is the minimum distance of the point from the origin. Phi, it is exactly the same as we have seen in the cylindrical coordinates, the angle made by the vertical half plane containing the required point with positive x-axis. And theta, as we have just seen, it is the angle made by the position vector of the given point with positive z-axis. Now let us discuss about the ranges for these coordinates. What are the maximum values these r, phi and theta can take if I want to cover the complete space? Let us talk about r first. Recall the definition of the r. It is the distance of the given point from the origin. Am I right? So if point P is, let us say, at a distance of 2 units from the origin, like this, then its r will be 2. If the given point is at a distance of 5 from the origin, then its r will be 5, like this. So the given point in the space can be anywhere. It can be at a distance of 2, 5, 10, 20, 100, 200, up to infinity. So the value of r coordinate can be anywhere between 0 to infinity. My dear, r cannot be negative, because it is the distance of the point from the origin. Or you can assume also like this: for getting the r coordinate of the point, we assume a hypothetical sphere centered at the origin is passing through the given point, and r coordinate of that point is nothing but the radius of this sphere. A point is like this, then its r coordinate will be nothing but the radius of this sphere. So radius of the sphere can be 0, but it cannot be negative. So what I'm trying to say, r can never be negative. Its minimum value is 0 and maximum value can be anywhere up to infinity. So the range for r coordinate is between 0 to infinity. The range for phi coordinate, we already know, we have completely seen in the cylindrical coordinate systems. The range for phi is from 0 to 2 pi. It is exactly the same over here. The range is from 0 to 2 pi. Now the last coordinate is theta. It is an angle. It is the minimum angle between the position vector of the given point, or r of that point, with the positive z-axis. Am I right? So if the point is in the first octant, like this, then its theta is shown in the figure. If the point is in fifth octant, then theta is like this. It is the angle between plus z and r. If the point is in second octant, then theta is like this. My dear, complete 3D space is divided into 8 octants because of these reference axes. And point can be anywhere in the space. We are assuming the maximum case, all the probabilities. That means point can be anywhere in the space. That means point can be anywhere within these one of the 8 octants. It can be in first octant, second octant, whatever. And this figure is showing theta for each case. So my dear, you can clearly observe from the figure that theta can take value from 0. Theta can be 0 if point is on the plus z axis. My dear, you are measuring theta from the plus z axis. So if point is itself on the plus z axis, then theta will be 0. So as you can see from the figure, theta can take value from here at 0 to maximum here. We can make one complete semicircle. Don't think that you can make a complete circle. For example, if you are finding the theta for this point, then you cannot move like this. You have to move like this for getting the theta. Because what is theta? It is the minimum angle between the plus z and position vector of the point, or r of the point. So you have to move like this. So what I am trying to say, You can clearly see from the figure, whichever be the octant of the point, theta can start from here to maximum up to here. That means from 0 to 180 or 0 to pi. So the range for theta is from 0 to pi. So range for r is from 0 to infinity. Range for phi, as we have already seen in the cylindrical, 0 to 2 pi, it is the angle. Range for theta, as we have just seen, it is from 0 to pi.